Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lesson, we wrote a bunch of code. Hopefully it wasn't too complex. Hopefully you were able to figure out what it was going to do even before we ran the example. Hopefully you got it to work just like I did in the video. Hopefully, even if it didn't work originally when you first tried it, you were able to narrow down what the problem was, either by using the F12 developer tools like we demonstrated in the previous lesson, or by simply kind of comparing line by line, looking at what I wrote in my code versus what you wrote in your code. Solving your own problems is a huge part of becoming a software developer, and sometimes you just have to develop that attention to detail to ferret out these little tiny details, a missing character or two that might exist in your code that's causing some problem or bug. And we'll talk about ways to do that and what the possible problems could be much later in this lesson. But nonetheless, in the previous lesson, I really didn't attempt to fully explain everything that you saw me do. Yeah, I made a few passing references to how this is wired up to that and so on, but I didn't really talk about what events were or what functions were or what variables were, so I want to do that right now. And what I want to do in this lesson is explain at a high level what's going on inside of this application that we wrote. Then we're going to spend the next 7 or 8 lessons speaking about each of the individual JavaScript syntax elements and concepts that we introduced in this video and in the previous video. So let's go ahead and get started. So you'll recall in our Hello World example, which you see open right here, that we added in the body tag an onload equals, all right, and we said that this code will fire, this JavaScript will fire whenever the page loads. Furthermore, if you recall in our c9js02.html page, we added this onClick equals to our input type equals submit button form element on our web page. And so I think this is a good place to start. What exactly is going on here with this onload and this onClick attribute? All right. Well, these are ways of accessing events that occur on our web page. And events are simply places where we can plug into the web page with our own code. And by plug into, I simply mean that we can write code that executes when those events occur. We plug into those events by telling JavaScript what to do when an event is raised by the web page. So for example, the onload event fires whenever the page finishes loading. So whenever, in this particular example, whenever the HTML is loaded into the web browser's memory, whenever all of the images from across the internet are loaded into memory, which this page references, as well as any external JavaScript files, external CSS files, and any other resources that it might need, at that point, the JavaScript engine will say, all right, we've officially loaded the web page. Is there any code for me to execute whenever the onload event has occurred? In this case, we say, yes, do this. Execute this alert hello world, okay? Similarly, we were able to execute JavaScript in response to a click event. Whenever the user clicks a button on our HTML page, we fired a specific chunk of code that had the name substitute. We'll talk about that in a second. So everything that we do in JavaScript is in response to an event that's raised in the web page, either something that happens during the life cycle of the web page naturally, like the page is loaded, right? Or in response to something that the user has done on the web page, like click a button in this particular case. Now, specifically in the second case, as we're looking at here, we're asking code to be executed by referencing a name of the code, a function with the name substitute. So we obviously wrote this function with the name substitute, so you can see the relationship between the work that we did here and the work that we did here, all right? And the function is simply a block of code that can be called or executed as a single unit. And it's defined as a single unit by wrapping this opening and closing set of curly braces around this block of code and then calling it a function. Now in this particular case, this function has a name. The name of this function is substitute. And so when the function has a name, we can call it by its name by simply referencing it and then also using these little operators, which in this case, this context means these are the function invocation operators. So execute the function with the name substitute. All right, and so then it will execute this entire block of code together. So we're going to learn more about functions in lesson number 6, but there's a good distinction to cement this idea in your mind, especially if you're coming from an object-oriented programming background like C# or Visual Basic. In VB and C#, you know that classes are the heart of those programming languages. But in JavaScript, things are a little bit different. The function, or rather the function object, is the focus, and understanding the flexibility of the function object and how it differs from other programming languages will ease your learning curve, and again, we'll talk about that more a little bit later. All right, so we started using functions at the very beginning. There are functions that are also built into JavaScript, or more correctly, they're built into the web browser's representation of the web page. This representation of the web page is referred to as the document object model, or rather the DOM, and you'll be hearing about the DOM for the rest of your programming career. In particular, in this example, we use the alert built-in function in order to pop a message box onto the web page, and we did the same thing here in our code as well. We also used another function called document.getElementById, which gave us access to a single HTML element inside of our code. So in this particular case, this whole line of code here that we wrote, we're saying, first of all, get a reference to an element that has the ID myTextBox. So what is returned is an object in the computer's memory that represents this tag called myTextBox, or has the ID of myTextBox, and then we use the dot syntax in order to access a property of that object. The property we're interested in is in the value, whatever was typed into the text box. And then we retrieve that entire value that was typed into the text box and we assign it to a variable. We'll talk about that in just a moment. So we use that dot operator all over the place. You notice that? We use it here, we use it here, we have it. Use it here as well, here again, and yeah, one more time here. All right. Eventually, we'll talk about all the operators that we use. The single equal sign, like right here for assignment, the double equal sign, and even there's a triple equal sign we'll talk about later on. The opening and closing curly braces, the parentheses we've already looked at. All right. All of these have a purpose and a significance in the JavaScript language, and we're going to talk about those in lessons 4 and 5. All right. So again, the getElementById built-in function gives us a reference to an object in the DOM that represents myTextBox. Then once we access the textbox element, we can grab out its value. In other words, whatever was typed into the text box by the user, and then we save that into a variable. And this is how we define a variable, var myValue. And we assign it immediately to the value that we retrieve. So you use the var keyword to create a function scoped variable. We'll talk about variables at length in the next lesson. For now, or 2 lessons from now. For now, just think of it as a bucket in the computer's memory where you can store your stuff, whatever that stuff is. And you know you'll need to reference that stuff. You'll need access to it later on in your code. So here we're storing the value that the user typed into the text box, and we intend to use that later on in our application here in the very last line of our function, where we're going to take that value and put it into, in this case, the title element. And we'll talk about that in a bit. Next up, we use an if statement to compare the value and to see how long it is or how many characters are in that value. In this case, we're using the dot operator to access a property of this object. This object represents a string value, and we're wanting to say how long is that string. If the string is equal to 0, which means the user hasn't typed anything into the text box, then we're going to execute this block of code as defined by the opening and closing curly braces. And we're going to, in this case, pop up a message and then exit the function by using this return keyword. Okay? So if, for example, somebody typed in the word Bob into the text box, the length would be 3, and 3 is not equal to 0, and so JavaScript's engine would completely ignore this block of code and would not execute it. All right? All right, next up, you can see that I'm using the document.getElementById one more time to reference the element that has the title or has the ID of title. You can see that gets us to this H1, and so now we have a reference to the object in the document object model that represents this H1 tag. Now we can manipulate it with our JavaScript by calling the inner HTML property, or rather using the HTML property to set and change what's in that header with whatever value was typed into the text box from this variable we retrieved at the very beginning of our function. All right, and there is a little bit of controversy around this inner HTML. I want to assure you it is part of HTML5. Previous versions of HTML do not include inner HTML as part of its specification. However, most browser vendors implemented it anyways. All right, so it's pretty safe to use it, but just be aware that it's not a standard if that's important to you. All right, so let's go ahead and make some more general observations now that we've walked through each line of code. All along, I encourage you to make sure that you type the code in correctly, exactly the way that I did it, using the exact use of periods and parentheses and quotations and double quotation marks and spaces and capitalization. As I pointed out before, programming is an exercise in preciseness, so everything matters. Every little character matters. And now the great news is that most web browsers and the JavaScript compiler in those browsers is that they're very forgiving. For example, you might have missed a semicolon at the very end of a line of code, like for example in this line of code. Let me just make that change and hit save, and then let's close this down and refresh our web page. And I'm willing to bet that this will still work even though our code syntactically is not 100% accurate. The fact of the matter is that the JavaScript compiler is very forgiving because there's so much sloppy code out there on the internet. If it wasn't forgiving and didn't try to understand what you were attempting to do, then probably, I don't know, 90% of the internet, of the web pages on the internet wouldn't even operate correctly. Okay, so we're thankful for that. However, we need to strive as programmers to write our code correctly so that it offers a consistent experience regardless of which browser that the user is currently browsing with. We can't rely on a forgiving JavaScript compiler because earlier versions of web browsers may not be as forgiving and a user encounters a problem that you didn't catch during development. So be precise. Be in the practice of being precise. Also, one other note. Each of the elements here, the periods, the parentheses, the quotes, the double quotes, semicolons, the equal signs, they're referred to as operators, and they each have a purpose and a meaning, and without them, the meaning, or if something were to change, if we use a different operator, it could potentially change the meaning of the code dramatically. Also, JavaScript has just a few keywords, words that have important meanings like function and var and if and return and so on. And you can't use, for example, the word var or return as the name of a block of code. You might get unpredictable results if you do that. JavaScript is a small language with relatively few operators and few keywords. The language is powerful because of the ways that these operators and these constructs can be combined to do some remarkably complex things. Unfortunately, that's also one of the sources of complexity in JavaScript beyond the fundamentals that you might run into. All right, so while I was typing the HTML, you may have seen a message about writing JavaScript inside of your HTML. What we did, for example, here and what we did here would be considered by professional JavaScript developers as a big no-no. You should never do this. In Lesson 11, I'm going to right the wrong that I've committed here, but I'm going to continue to take this route because it's the easiest way to include JavaScript inside of your applications. Later on, we're going to focus on doing it the right way. So if you're an expert, you're watching this just for fun, and you're about to write me a note, a nasty note in the comments, I just want to say up front, I acknowledge that what I'm doing here probably isn't the best practice. Please know that I do plan on discussing the separation of HTML purely for content, CSS for appearance, and JavaScript strictly for behavior into separate files. All right, we'll get to that. All right, so after we typed all this code out into our web page and we attempted to run the application in our browser, the browser first attempted to acquire all the external files like images and external CSS or JavaScript files and then make sense of it all. In order to make sense of it all, it constructs an object model for your web page, like I said a little bit ago, the document object model, or rather the DOM. We'll discuss the DOM in depth in lesson number 13. But while it's constructing the document object model, it'll give JavaScript developers an opportunity to execute code at certain various points in that process. And this is where the load event comes in. And so we can write code that will execute in response to that particular event. The easiest way to write that code, as we did here, is just in the body to add an attribute onload equals. And there are other ways as well. However, the caveat is that the document object model may not yet be completely finished loading. So if we write JavaScript code that references some element in the web page, it may not be available at the point when the onload page has the onload function has executed, or prior to that. So that's quite a pickle, and I'll explain this situation in much more depth in lesson number 15, I believe, when we talk about events. And ultimately, we'll have to keep our JavaScript pretty simple until then, but there is a very good solution for that as we move to jQuery. So let's move back to our C9JSO2.html page. You will recall that in order to demonstrate the use of the F12 developer tools, I wanted to break our web page intentionally by removing the E off of the word substitute, because now it's no longer named exactly the same as our function, right? And so we demonstrated in the F12 tools how it wasn't able to find this function because it doesn't exist by that name. So when you inadvertently introduce an error into your application, depending on the error, the application may not work at all, or it might break at some point during the execution of your program. Your user might get a message indicating that the application is broken, or it might be hidden from them. And so modern browsers today typically hide exceptions because there are so many poorly coded JavaScript web pages out on the internet. It would be burdensome as an end user to go to every web page and see, browser error messages keep popping up. You'd never be able to get anywhere on the internet. So the burden is on the developer to make sure that the code has no errors before you release it into the wild. And there are two different types of errors that can happen in your JavaScript. First of all, you can have syntax errors, and these are things like forgetting a closing quotation mark or parentheses or a semicolon like we did. In other words, the code is improperly formatted. Then there's also runtime exceptions, and these pop up because there's an undefined variable or you attempted to call a non-existent methods. For example, the substitute, let me fix that before I forget it. That's a good example of a runtime exception. It didn't occur until we actually clicked the button, and then we saw the message in the F12 developer tools that said there was a problem. Runtime exceptions also occur when something outside of the developer's control happens. So a good example of that is whenever you're going to use AJAX to make a call back to the web server. And AJAX is simply a technology that allows the web client, the web page, to contact the web server in order to retrieve tiny bits of information instead of a full post of the entire web page's form element back to the web server. We'll talk about AJAX much later, but let's suppose on any given day that the web server is having problems and it's not able to serve up the data that our web page is expecting correctly. And so as a web developer, we have to account for this possibility. That the information we're retrieving back is going to be garbled, or it times out, or whatever the case might be. We have to make sure that we degrade gracefully in that situation. Now, fortunately, most of these things have already been thought out for us, and we'll talk about situations like these near the end of this video series and how you can insulate the code that you write against those kinds of problems. So again, let's just put that a peg in that, and we'll come back to it later. All right, but here's some general advice when it comes to syntax errors and runtime exceptions. If you're testing your code prior to putting web pages out on the internet, Or if you're building a WinRT application for Windows 8, your end user should never encounter a syntax error or a runtime exception due to something that you could have prevented. Period. No exceptions to this. The burden is on you to test in as many different browsers and as many different environments as you possibly can before releasing that web page or that application into the wild. But again, there are things that are out of the control of you as the developer. For example, some external resource that might be missing from a web server, or the web server is having issues. If it's down or having problems, you can't control that, right? But you can and you should guard against that possibility. And we're going to outline some ways that you can do that later on in the series. All right, one thing we didn't do at the end of the video was to make sure that all this code we wrote actually validates. So I just hit Control A, Control C to select all and copy, respectively, onto the clipboard. Let's open up Internet Explorer, and in our validator, we'll paste in the code that we wrote, and we'll click Validate. And we still get that warning, but I'm going to ignore that warning. The good news is that the validator does consider this to be valid HTML5, and that's all we're looking for. Great. Okay, so one last thought here before we conclude. We're taking a challenging route in this series by only using Notepad and Internet Explorer. That's fine. We want to keep this simple. We chose this route to make it obvious to you that you don't have to use a particular tool, and we didn't want to require you to download a tool and install it in order to develop JavaScript applications. It's as easy as using stuff you've already got installed on your computer. However, having said that, there are free tools from Microsoft, most notably Visual Web Developer Express Edition. It can help speed your development time and ensure greater accuracy as you type in your JavaScript. And I'm going to demonstrate how that works in the very next video, so make sure you watch that. But then we'll be back to using Notepad for the remainder of this video series. Okay, so we'll see you in the next video. Thank you very much.